two reasons you can give, right? If you turn the picture like that, we have angles in the same segment concept. What's that? DE makes an angle 32. The same DE makes an angle there also. So angles in the same segment. If you don't like that, we can look at the isosceles triangle concept again, because we got one radius, another one, 2, right? So base angles should be equal. That's how one needs to find all the different angles. Mostly I think we applied isosceles triangle and right angled triangle rules. Okay, now not bad. This question is a very easy one. There's only one rule that we applied, which we learned in this lesson. That's radius and tangent. The angle between them is 90, right? Of that, can we move to question 8? Page 8, please. Let's move to page 8. In this video, say, mostly we are simply finding the missing angles. Of course, we are supposed to give valid reasons that I will explain in miscellaneous exercise later. So, look for the page 8, that's on the screen now. Okay, page 8 is on the screen, and question on page 8. There is only one question, please. Once again, we have tangents, and let's write their tangent before we forget. So that line is a tangent, right? Tangent. Now, where do we start? They said, well, find all the angles that you can. Okay, right. Do we have a center point? That's how you need to think first. Center point is there. A line is passing through the center point, and therefore we know that we have semicircles on both sides there, right? Angle in a semicircle is a right angle. That's a rule, right? Can I say that's a semicircle and therefore the angle there should be 90? Come on, think. Can I say that this angle is 90? Please listen. The angle should be on the circumference, and also the angle should be made by EC, which is diameter, right? Do not forget, please. What we learnt was not simply angle in a semicircle is 90, but if you say angle made by diameter on the semicircle, that makes sense. So that is not 90, but this side it is 90. Watch the triangle ETC. Triangle ETC, it's a semicircle, and the full angle there should be 90. Okay, that is 90, please. That should be 90. We know the small angle there is 40, so we can easily find this inside angle there, that angle, this much only. Okay, that should be, come on, 50, right? It's a 40, so that should be 50. Together it makes 90 there, right? Okay, we got two angles. It's a 50, that's 25, that's 40. Now, can you find this angle here? Come on, think. Is there a way you can find this angle? Triangle ETC, concentrate on that and tell me, is there a way you can find this angle, please? This is 90, we know. And that angle is 25. What should be this? Together, it should be 90 again, because it's triangle concept. Three angles of a triangle concept, please. Right, so 90 minus 20 is 70. Take the 5 away, 65. So that should be a 65 degrees. That angle there should be 65. Please listen, simple triangle rules, sum of the three angles. Now, we need to look at this angle, that angle, please. Let's go and see. We need to turn the picture like that so that we got angle at the center concept. Angle at the center is this, made by DE chord. Okay, the same chord is making an angle 50. That is 50. Please watch that. That angle there is 50. So angle at the top, you know, the star and the dot, right? Angle at the top should be half the angle at the center. We learnt in part 1. So if that's a 50, this should be 100. That should be 100. Okay. Angle at the center is double the angle made by the same chord at the remaining part of the circle, please. Now, any more missing angles we can find? Well, this is 100, so we know how to find that angle there. That much should be 80, right? There are so many ways you can actually do. Can you find these angles now? Come on, those two. This is a 100. Okay, think. Isosceles triangle. We got radius there. Watch, please. OD radius and OE is also radius. So two sides equal there. That is equal to this. Base angles must be same. Those two should be equal. So three angles add up to 180. We take the 100 away first. We are left with 80. You know that's a 40 and that's a 40. Right? There are so many missing ones we can actually find. Now, one more angle concentration, please. I want you to think very carefully in this case. I want you to answer. I want you to go and find this angle here. The angle between tangent and chord, between TB and TC. Can you find this angle? Is there a way you can find that angle? Come on. Is there a way you can find this angle? We know that's 65. We got a triangle called CTB. I'm interested in this angle here, right? Angle between tangent and chord. Okay, that's the concept one needs to look at. Now, is there an angle formed by TC? You got to know the alternate segment here. Watch there. That's TC. This is the angle between tangent and chord. I'm looking at that complete part there, which is the alternate segment. In this alternate segment, TC should make an angle on the circle, please, right, on. So the same TC makes an angle there at E, which is 25, and this angle should be 25. Okay, that's how you can find. And then maybe you can also find the angle at C. Just go and see angle at C. That line is a straight line. That's a 65. So you can find this angle. Once you get this angle, use the concept of triangle CTB. Three angles add up to 180. You can find this angle. Did we leave any more? Maybe check there. What should be this angle here? Now this is interesting angle, please. This is also angle between tangent and chord, right? This is the chord.